Hey, welcome to a Unity tutorial with Mike, myself, and I am here with Dylan.
Hi.
And we're going to be showing off a very early build of UTiled, a tiled map import support. What would you say? Package?
I would say import, I guess.
Importer, tiled map importer for Unity. That mostly I've been working on. We'll probably work together on it more for our games here, but we're going to start off here and open up Unity. We are running this in Unity 4.3. And the first thing I want to do is just go ahead. We're just going to make a new, I know this is a blank scene that we have here, but I'm just going to start from the very beginning with a new project that I'm going to put in this. I'm going to get rid of this. I should have done that before. So, well, that didn't actually do anything, did it? Oh, there it went. Did it? What? Oh,
yeah.
Already messing up the demo. Okay. I'm just going to call it demo and select that folder. The reason I wanted to start over again, though, is to show you that you want to come down, and in Unity 4.3, you can now set up your defaults for 2D. You can do everything here in 3D. There's nothing particular to one or the other, but this just sets up the layout and the default camera and things like that for a 2D game versus a 3D game. And for tiled maps, 9 times out of 10, this is going to be a 2D game. So you kind of get the basics here. What's really set here is that your camera is orthographic, and set up some other things for 2D and 2D asset flow, make things a lot easier. So the first thing that you're going to want to do is obviously, have a tiled map to work with. And so I'm going to go ahead and in my assets folder, I'm just going to make a directory for maps and show this in Explorer here real quick. Come over on my desktop. We've got some stuff we want to bring in here. Just some rocks. So that just comes in as the normal image here in Unity. And I'm now going to open up Tiled. Okay, didn't find the old file because I just deleted it. We're going to make a new map here. Orthogonal is all that is supported at the moment, and the format needs to be either XML or CSV. Not supporting, this initial version does not support compression. It's not in mono, which is why it hasn't been implemented. The system compression namespace that I've used before on doing tiled in XNA. So I'm making this map 30 tiles by 10 tiles and 48 by 48, which is what my tile sheet's set to. It gives me a nice resolution down here. The tiled map program, this is something that we did not make. We're just using tiled. You can go to mapeditor.org to check it out and download it, learn a lot about it. And we are not the only option. If you come to documentation and you look for support for TMX maps, you'll find a large list of projects, some free, some open source, some commercial, that support out-of-the-box TMX maps. So we are just one of many, and there are even some other Unity options that you can come check out. The reason that I'm creating UTiled is I want to do it myself. There's nothing wrong with that. And also to try to implement it in a Unity native way as possible. As much as I can, utilize the built-in features of Unity with the built-in features of Tiled, and not create a third system that you have to integrate with to take advantage of it. Okay, so that's Tiled. It looks kind of blank at the moment because you can't really see anything. So I like to come in on Tiled and show my grid, which shows my 30 by 10 map. So that's what the map looks like. I'm going to quickly add, I'm not going to explain too much. If you got any questions, jump in, but I'm going to add a tile set. Now, it is important Actually, I didn't save this, did I? Okay, so before I add that, you want to save the map, and I'm going to make sure I save it in my demo maps folder here. I'm going to call this level 1. Imagine we're making a game with multiple levels. And I just want to make sure that... No, I did not. I go ahead and move my rocks into the same directory. So I just want to make sure I'm not going to have any weird path issues. So here's my level 1 map that I just saved. Note right now Unity doesn't know what to do with this file at all. And I put the image, if I show it in Explorer, right next to it so that when the TMX file references it, it won't have any weird path issues that can bite you later. It's not going to hurt to have it, but it can definitely come up later.
If you move the Unity project around, then...
Your paths, if you accidentally had a hard-coded C directory in there, it could make it a pain on...
If you're sharing this with other people through
teams,
source control.
Exactly. So, new tile set now. Now I can browse and... Assets, maps, rocks, PNG. And this is a 48 by 48 tile. There's margin and spacing options and offsets. All that is supported right now in UTiled, but this is our very first release. So while I've tried to handle all kinds of crazy edge cases and combinations, something may be off. So just know that it should work, and if it doesn't, get in touch and we'll try to repo it and debug it. So the first thing I like to do is I'm going to rename this first layer I got here. I'm going to call that background. And grab the flood fill tool and grab blue and just kind of make like a blue sky. And then I will go ahead and turn back off the show grid. So I've got something that's showing me my map. I'm going to add a new layer here for our platforms. And for our platforms, I'm basically... Oh, I still got the flood tool on. Okay. I'm going to run this across the bottom. I'm going to leave a little gap here. Make like a staircase. I'm going to grab the grass one here. It's very 1-1-ish, I would say.
Yeah.
And why not just go ahead and throw out a little platform there and a platform there. We're not going to get into jumping and creating a platformer game. We're just kind of showing a basics of tile. Now, I've also made a little cloud here, so I'm going to go ahead and put a cloud there and a cloud there, and I'm going to use tiled, whoop, that's rotate. I don't want rotate, I want flip. There we go, flip. To go ahead and flip and make some other, right there. So there's our little 1-1 world. And I'm going to save it. And you know what? Oh, I think I just... Alright, so I put the clouds on the platforming layer.
Yeah, I didn't know if you were going to... that was going to be a separate step.
Feel free to shout that out. And say, what are you doing? This is not what we talked about.
I did not know if that was intentional.
I'm going to put one there, I'm going to put one there. Come back here to undo my flipping. Put one there, put one there. Now I'm going to turn off the cloud layer so I don't see it. And I'm going to turn off the background layer so I don't see it. I'm going to go to the eraser, make sure.
The key with the clouds is those are actually 2 tiles,
Yes, so one cool thing is you can select multiple tiles down here and be able to paint those at once. Like, this won't make any sense, but I'll grab all 4 of these, and I could paste it 4. You could also right-click and select a group, and then you can have, like, if you wanted to make a ceiling or something like that, match like that. A lot of cool things. The reason we're doing this is we love this tool. This is a really cool tool. Some other things that you can do in this tool is I could click on clouds here, for example, and click on, let's see, right click, here we go, layer properties, and we can add some custom properties. Let's say I'll put a layer type in my game, and it will be, pretty things. Like, this is just something to look at. Obviously, these are probably pretty horrible. You probably have something more like, affected by wind. And then you could put over here true. And then use that in your game to animate that layer or something. That might be data that's important to you. You can also do this at the map level. So map properties, world 1, level 1, so that we would know, you know, encode what we were dealing with, what we were working with. You can put those properties there. So, and there are other places to stick properties and things that we're not going to go into for this demo. So there we go. That's the basics. I'm going to save it here and come back to Unity. Now, Unity's not doing anything with this at the moment. It knows nothing about this. There's no support built into Unity for tile maps. So what we need to do is add in UTiled at this point. Now you get UTiled. You come over to bitbucket.org/vinyl/utiled and come over to the downloads. And right now the version out that we're doing this for is 0.5. We just arbitrarily picked the first one and said it feels like a 0.5. It could be plus or minus a point. You know, it could be a 0.4. It could be a 0.6.
How that increases will kind of is iffy right now.
1.0 will definitely be when I can say we are feature complete with the tiled map format.
Yeah.
So we may go beyond 1.0 and add features for Unity that are advanced for working with maps, but 1.0 will be the point when I say all the features, that everything that you can do in tiled, you can now access in Unity. Okay. So download this guy, save him somewhere. I've got him on my desktop. And in fact, I don't need this anymore. I can just get rid of that window. And you come over to assets, and you want to import a package. And you select a custom package here, and go to wherever you downloaded it. Mine is on my desktop. And grab the package, and when you open it, it's going to say, hey, I've got a couple folders here and a bunch of code. And you just want all of this, so you just hit import. And it'll take a second to compile the scripts, and then you get a UTiled folder. For the moment, we don't need to mess with this at all. But now, if we re-import, now we have a Unity object that's beginning to parse things. There is one little change I do like to make at the beginning of my Unity projects. This is just totally me. It makes me feel comfortable. It makes me feel at home.
Cornflower blue.
I feel a little more easy, yeah. So 100, 149, 237.
I haven't even memorized that. That's I would say impressive, but I don't know that that's the word to use.
I think some of our audience, this may help. This may make you feel a little, just seeing that down there feels like, that's a new game. That feels like a new game. That's a new game color. Okay. Roll back on track here. So, what this is doing is this gives us control over the import, and we're going to make some prefabs that we can use in our game. You know what I haven't done?
What?
I haven't saved the scene.
You should probably do that.
I should probably just hit Control S here, and it says, hey, you've not saved the scene, so we're just going to call this main. And I'm not going to worry about foldering it or anything because we're not going to get complicated here. Okay, so what this import setting here right now, those are our layers that we had defined and tiled. And checkboxes if we want render and collision. I'll come back to collision in a moment, but we're just going to take the defaults. And we get a folder named the same thing. Now, I try to keep this down to a minimum, but it does get to be a lot. What it generated was some meshes and some materials. We don't need to go too deep into those because we have this nice prefab object. You can even see in the preview of our level. And so I'm going to drop that on the surface, but that's not what you're kind of expecting, I think.
No.
So at this point, we have to kind of open up into a discussion of 2D and camera and getting pixel perfect. You know, a lot of people want to make sure that their 2D games are rendered pixel perfect. And UTiled is set for you to assume you want a pixel perfect world. You do have to give it some help, though. So the first thing we need to do is we need to reset our camera. I'm scrolling out here quite a bit to see the size of the map. In Unity, there is a concept of pixels to units. And these are how many pixels map to how many space units, which are completely arbitrary, in the editor. For us, this defaults to 100, but once you import that texture as part of a map, UTiled is going to set it 1:1. This makes calculations a lot easier, and when you start dealing with the level object, if I want to move this in the x-axis by 100 pixels, I can just come over here and type 100, and it will move 100 pixels. In our case, if I want to move 2 tiles, which would be 96, because we're in a 48 tile map, it would be 96, and then I could move over completely by 2 tiles. So we're setting up the base Unity tools to work in a pixel level. And, you know, this was a decision I wrestled with, and I played around, and in the end I decided it was easiest to just have an opinion with UTiled than try to be generic and support everything else. Not to say you couldn't come in here, begin readjusting your pixels to units, and adjusting your settings, and you may have to make some adjustments on your camera and things like that. It would still work. What we're expecting for this all to work on our camera is we basically have to tell our camera that we're in a 1:1 mode. And this kind of plays in with how big is our screen going to be. So by default, Unity's in the free aspect mode. Because we're recording this at 720p, 1280 by 720, we're going to go ahead and set this game up to be 640 by 480. That's just so it fits in our window. If we maximize on play here, I just want this window to fit in our record screen when we do that. So we're choosing 640 by 480. The equation here is to adjust your orthographic size on your camera. So here's my camera, and this size field is the orthographic size because we're in projection orthographic. And if I click on it, well, you can't see it at the moment, so let me zoom in. If I click on it right now, this size of 5 is our orthographic dimensions. This 5 is actually the height and the width. I'm sorry, the height. So you adjust it by the screen height, which is 480, divided by 2, divided by your pixels to units mapping,
which is 1.
In our case, it's 1. And the reason we made it 1 is because it simplifies it. So you can just forget, divide by 1, you can just cross it off. And divide by or multiply by any kind of zoom or scaling factor you want for your game. I'm going to assume that we're going for 1:1. 1 pixel on screen is 1 pixel for us. So it makes it really easy to simplify that equation. Divide our screen height by 2 and set our orthographic size to that. So if it's 480, I'm going to set this to 240 and bam. Now, if I frame back up on my camera, there we go. If I frame back up on the camera here and click the camera, you can now see that it lines up perfectly with the top and bottom, because both the level and the camera are at the origin 00.
Now, I guess it might bear pointing out that if you're targeting, we're targeting 640 by 480. If, say, this was a mobile game or something where we didn't have control over what resolution it was being shown at, it would still, the vertical size of the screen would still be, this is essentially what we'd see. It would just be scaled up or down.
Correct.
And we would see more on the sides, depending on what the aspect ratio was.
We can demo that real quick. Let's go ahead and do a build and show some of that in action at the moment. So I'm going to build, I got to add my current scene here. I'm going to build for Windows, not really changing anything here. I'm just going to build it. It wants to know where do we want to stick it right now. I don't want to stick it in the project folder itself. So I'll make a new folder for build outside of the project. Just call it demo. And when we can run this, so if I run it at 640 by 480 in a window, the game comes up here. You can see it's matching exactly what we have in our screen. Now, as Dylan just said, if I come back to this and we'll run it again, And I'll run it 800 by 600. Now, we are scaled up, okay? So, the pixels are no longer 1-to-1, and you can see a little artifacting going on because it's made the pixels larger, but it still is showing exactly what it shows at 640 by 480. And the last thing that Dylan mentioned here, if I change it to 720 by 480, so I've gone with a different aspect ratio now, it's a little wider. The camera is set by height. So at this point now, you will see a little more to the left and right, but never more to the top or bottom. That's the way that we're set to scale. If, however, you wanted to have that change, not resize, but just show more in both directions, I'll show you real quick here. You can just implement that, I'll call it camera size. I'm going to drop this camera size script on my camera. And then open this up real quick here. And so what you want to do is set the camera orthographic size. It's just called size in the editor, but it is orthographic size property to screen width divided by 2 divided by the pixel aspect ratio, which in our case is 1/1, so we can just leave it out. But if you had adjusted that, you would need to add that in right there. So now if I set that at runtime, I'll just do it within the editor here. So at 640 by 480, if I hit play, it's gonna, I did have it 640 by 480, right? What did I just do wrong? I typed in screen width. So, like I said, it's based off the screen height. And if we run this now in the header, there we've got the exact same thing that we want. If I come in here and go medium now, you can see it's extended in both directions, okay? But the pixels have remained 1-to-1. So now I've just adjusted the game to run in that. But, okay, so we've gotten off a little bit, and we got a little complicated there. I'll go ahead and get rid of this camera script and get that off there, and we're going to stay at 640 by 480 for this demo. And we're going to say scaled at 240 for this demo. What I do want to add in real quick is I'll go ahead and make another C# script. A little camera mover. And for this guy, we're going to require a component here. So this is kind of a neat little Unity thing that you can do. But we're going to need a character controller on the camera. Not common, because normally you control a character. But that's just so I want to be able to come here and character controller. Okay. I'm going to initialize him in the startup so we get a reference to him with get component. And then finally, I can use him. For this demo, we're only going to move on the x-axis. If you wanted, you could add x, y, and z to this vector 3 here, but take the input, we're going to get the axis for the horizontal. Use that value as our x. We're going to keep our y and our z locked, so the camera's going to wiggle back and forth. I do have to do a couple other things to this. First of all, that's going to run wild in the frame rate, so we do need to bring in our time, delta time, so that we keep it locked to a frame rate, and therefore we should also go ahead and add a speed modifier, and I'll just go ahead and make a public float speed that I can edit from in the editor. So because I threw on this require component here, and when I come back into Unity and I grab my camera and I drag and drop on, it's missing a script, so I'm just going to take over the missing script. Well, it didn't do it. Well, let me go ahead and remove it and drop it this way. There we go. It automatically added the character controller because that was a required component. I don't need to mess with any settings on the character controller because it's using it for movement. And because we're in pixels, I can say, well, and we've locked to our frame rate with the delta time, this value, speed, becomes pixels per second. So if I want to move 2 tiles per second, I can set it to 96. And that speed then will allow the camera to move about 96 pixels a second. It's a little slow. I'm going to go ahead and set it up to about 200 pixels a second. I think that's a good value for the demo so that we can go back and forth. So really all the interactivity that we're going to do in the game. You can turn on stats here. We're running at a good 80 frames per second still. We have 3 draw calls going on.
One for each layer?
One for each layer. And you can see the number of vertices in use, 1.5, etc. triangles on it. So we're no performance problems to worry about yet. Of course, we don't have like hardly anything of a game. So the other thing that, while we're talking about all this pixel perfectness, is I kind of want to show an edge case here, or at least what the effects can be when you have it set wrong. I'm going to come back to our level map here, and I'm going to add a layer. We're going to call it lines. And I'm going to take this block that we made earlier to demo this effect, and just put it over the entire top. You can even see in tiled that you can't see all the lines here because of the zoom level and the scaling. Now, if I zoom in enough, they all start to come in and they all start to become crisp. But even then, all these lines are the same width, but they don't have the appearance. Some look darker, some look lighter. And that's just because we're not pixel perfect. We're not lining up. Every pixel is not lining up evenly on a screen pixel. Every source pixel from the image is not lining up on a screen pixel. So when I save that, I'm going to remove our level here and come back here. It's already picked up. If it doesn't pick up over here, you can just right click on the TMX map and do a re-import to get it to pick up any changes. We're going to generate our prefab, so let me drop it back over. And now you can see these lines don't look great. When I click away, you can see the tile lines up here don't look great. That's because both of these windows are scaled. But our camera is actually set for 640 by 480, and we are in 640 by 480. So I'm going to let it maximize on play. And now you can see that it actually, when it's at the size it expects to be, you can see every pixel. Zooming in and zooming out, you'll see it kind of pop in, pop out. The diagonal gets really janky and ugly. I'm doing this in the designer window, but you could see the same effect down here. I'll go ahead and go free aspect and just play with the size, the orthographic size of a camera. And as it zooms in and zooms out, you can kind of tell that the same thing happens. Those diagonals look like they miss pixels and they look like they double up. Some lines look thinner, some lines look skinnier. And so that's basically what's going to happen when you don't have all these in sync together to get pixel perfect rendering like this. Alright, I'm going to get rid of that layer because we don't... that was just for the demo purposes there. Okay. So now that we've done that, we've added it, we've got it on here, some things are set the Unity way that you can begin to explore around a bit. So one thing that it did, other than setting our pixel units to 1, is Unity actually went ahead and created sprites as defined by our tiled sprite sheet. So our tiled sprite sheet defines all these sprites. Now, we made this cloud, right, defined on 2. So you're not limited. I can come into the sprite editor. This is Unity sprite editor. This is not mine. And I can come into slicing. And I don't want to auto slice. I want to maybe because I've never sliced, it thinks I need to slice. I don't want automatic slicing. Grid, center. No. I want custom slicing. And I'm failing at the moment. This is the one thing we did not rehearse. And I just thought I would do it on the fly, in the moment. I can delete this guy, come over here, grab him, stretch him, and then trim in there, and I'll go ahead and hit apply. Tiled is not using that data. I should have renamed it though, because when I re-import it, it will overwrite it. But for this, I'll just bring him in like that. Now you don't see him. He's right there in the center, but we're not seeing him at the moment because of his sorting layer. So in Unity 2D now, you have this concept of sorting layers and orders within that layer. And by default, all the layers came in, sorting layer default, and they came in numbered. The clouds were on top, so they were 3. Then the platforms were 2, and the backgrounds were in the back at 1. When I drag him on there, he went 0. So he's behind the background right now. So where I really want him is in front of the background, and I actually want him on the cloud layer, which is 3. So I could just set him to sort layer 3, and now he appears as we expect. And move him around. Maybe he goes over here. Move him around and set him out. I can also, if I want, instead of that, I can put it back to 0. And the sorting layers, we can come in and you can add more sorting layers, custom clouds. Okay. And now that that's set, I can come back to him and I can assign him the custom clouds. And if you come into your sorting layers, I can drag the order of that and he disappears. I can put it back up and he appears. So that's what sorting layers do. They group up items and then within each layer, there's an order. But you're also free, if I want to take the clouds layer that I have, I can go ahead and take that and move that to the custom clouds layer. I'm going to leave the order 0, I think, is what we left him at. Yes, so they're all in the same order. But now when I come into my layers, all the clouds will move together. So basically, we've added support for the default sorting layers. Now what's going on is this is a custom layer object, and these properties are applying to all of the meshes that are loaded up beneath the layers. And right now we got the 1 mesh per layer going on, so it's not a whole lot. We'll have a more complicated map later to look at, but every renderer, if you're using a Sprite shader, does have a sorting layer and an order in that layer, but right now Unity does not expose that on the mesh renderers. It only exposes that to the Sprite renderers. So UTiled is adding some helper code to manipulate that so that you don't have to go in there and do that. So that's kind of overview what we got going on at the moment. I'm going to lose that sprite because I'm going to come down here. I'm going to import the collision meshes now. And it restored, because I kept the name the same and I didn't rename it, it overwrote it. I should have changed the name and it wouldn't have done that. But there, it recreated that sprite, so we're just gonna get rid of him. We don't need him at all. And my prefab connection, they break right now when I regenerate the map. So that's something on my to-do list, is to look into not breaking that prefab connection when you regenerate the map. But for the moment, that happens. So now that I've brought in collision layers, you can see these nice little green lines that come up when you select one of the layers. And each layer now has a collision mesh, which can be used. It's on a mesh collider, and that can be used to trigger and do all sorts of collision and bounding boxes and everything like that in Unity, and play with the physics system and everything. So we have the option here of just going ahead and taking a layer and taking the render mesh, which is this one, and just turning it into a collision mesh as well. Now, I do some optimization, because when you have these platforms here, here is the platforms. The platforms has 264 vertices and 132 triangles, but the collision mesh only has 112 vertices, same number of triangles. The reason of that, let's zoom in real tight here. And we're looking at this tile right here. He has 4 vertices. 1, 2, 3, and 4. And from those vertices define this triangle and that triangle. And then the guy next to him has 1, 2, 3, and 4. Now, they share these 2 vertices. They overlap. On the render mesh, though, they're actually entered twice. On the collision mesh, it's only used once. The reason it's twice on the render map is I need to set UV coordinates here. And the UV coordinate on this side is for this source tile, and on this side is a different source tile. So it actually needs to have 2 different vertices to have 2 different UV points. But when you go to a collision mesh, that just has a lot of redundant, I would say, tile vertice information. So it goes ahead and simplifies that. But it does take a little bit to do that simplification and that work. So when we imported here, we imported all of it. Well, we're never going to worry about collision with the background. We're actually not going to care about collision with the clouds either. So with the background and the clouds, we don't need those collision meshes. The reason that we have an option here is that we really only want collision on the platform layers. The other 2 are just a lot of extra data we don't want to have to keep up with, and it slows down your import and your regeneration. But we may actually be able to do better than just using the platform layer. We can simplify this a little further. So I'm going to come back to tiled, and let's add a layer called collision. And on this layer, I'm going to take my red block here, and we actually only want to check these. This one, this one, this one, this one, and these platforms. So we can enhance things a little further by not using the platform mesh, but by generating another tile layer. And now we have collision just on the collision layer, which we may not want to render it. I rendered it here just so you could see it. We can also come in here, and one of the things you can do from the top is adjust the opacity. So if you want to have a method in the game for debugging, fire up a console and go ahead and like show me my collision layers because I need to debug some things. That is an option there as well with that. So in the future, we don't support object layers, but I just want to show you right now. I'm going to go ahead and turn on the show grid, and I'm going to make an object layer. We'll call it collision. And on my object layer, I'm going to create a polygon. And I can just draw out here the polygons that I want. I think I messed that up pretty bad, but I can just draw along the polygons. I can turn off all the other. And I think if I layer properties, set that to a nice bright red. There we go. Now we can see that better. Well, not when I get everything else on. Red on top of those bricks is not great. Okay. Now that I can see that better, that actually would create a much cleaner collision mesh, and I could get in there and not have a bunch of vertices repeated. At the moment, we don't have any support in UTiled yet for object layers, but that is coming. For the moment, though, we could do it just by painting on tiles. Okay, so we've covered the sorting layers and we've covered collision meshes. The other thing that we haven't touched yet on is the properties. If you remember the properties we added in the beginning. If you click on these layers, I added affected by wind is true and layer type pretty things. You can see that over here. I can edit these if I want. And just say layer type should have been clouds. And get that. And then I can add more. Or I can just delete it. We didn't have any properties on background, so it did not generate a properties component. But if you want to add it, you can come down and open up the UTiled folder and just go to UTiled properties and drag that component on, and then you can get properties. And you can actually add these properties to anything. It's not limited to, it could be added to any game object.
It's basically just a way of handling data that Tiled provides. Correct.
So, last thing here is how do we access these in code? Because that's really where they're going to be used. They're going to be loaded up in code. So what I'm going to do is I'll just add a script. And, oh, there's not an add new script on here, is there?
You have to do it
the new script. There it is. New script is prop reader. Okay. Create and add. There we go. Got my prop reader. So I'll come into property reader here. And we'll just go ahead. And you know what? I'm not going to get real fancy about this. So I'm just going to show how we access this and do a debug message just to show access. So what we need here is UTiled properties. And here, you either need to add the namespace, Funkworks, Unity, UTiled, or spell it all out. And the reason that we did that, we're not egocentric about it. We're just, if you're not familiar with a lot of .NET, if you've come to Unity from other systems, and this is kind of Mono and C# is your, Unity is your first introduction, it's very common to name it the company first in your namespace. And then group it up under that. So we've kind of grouped up Funkworks and then our Unity projects, and then a specific project is UTiled. And the reason the company name goes first is so that if you were to go and modify UTiled, then you could just come in here and put in your company, Awesome Games, change the namespace, and now you don't have to worry about a conflict. So you could just change one piece of it, and you won't have to worry about a conflict with the namespace. Alright, so props equals, all we have to do is get component, and I'm going to drop this all out and go with the other method, which is add the using statement up here, so that I can just see them all in my autocomplete. And that gets the reference to the properties. On properties, we have quite a few helper methods. So, we can get a value for a property, and in which case we would just pass it in, and that would echo back out. So let's just go ahead and do a debug log. There we go. And I will come back into Unity. We'll go ahead and run our game. And, oh, I still have maximize on play, so that's kind of annoying. Let's get that off. So we'll run the game. The game started. We come over to our console, and there you can see it printed out the value of that property. That is the basics. Come back into property reader. So we have get value. We could also, since we know this is an integer, we could get value as an int, which returns a nullable integer. It's going to try to parse. All properties in tiled come across as strings. There's no typing involved, but you may be able to send something over as an int, a float, a bool, and this just makes it easier for you to get it that way. If you want to get all the properties, then we could do props, properties. This is an array, essentially. I don't know where my cursor just went. Oh, it went all the way up there. Okay. And here, we'll just debug log. We'll do p.name. Come back to Unity. Run the game. And now you can see it grabbed each one and printed them out. So that's the basics of accessing it from a script. Nothing magic going on there. It's basic. I don't like looking at my collision layer, so I'm just gonna turn it off. I like my little clouds and my little world. So we've covered everything else. Now I want to show you large maps, because they kind of introduce their own sets of issues. So let's go ahead and, let's see, do I have an Explorer window up? I do over here. Let's get into our demo project, our assets, our maps file. And, you know what? I'm not even going to pollute that directory. I'm going to bring over a map, the fans of Funkworks may know. I'm going to bring over the Captain Dubstep map. So it's going to import the images. Now the images, let me just show you here. By default, they went to pixel units 100. So that is going to get reset to 1 when we do an import. And also, the only sprite it identified was the whole thing by automatic, and we will slice that up for you automatically. I'm going to go ahead and open the Moonbase map in tiled. Let me zoom out. Let me zoom out. Let me zoom out. So this map is huge.
This is going to be the entire game.
This was the plan.
Basically.
This entire thing was planned to be a game. We overreached by a long shot. What is filled in here, let me turn off the grid. What is filled in here is the amount of map that we completed for Dream Build Play. That little chunk there. Let me come to map properties here real quick. Resize map. So, this map is 864 by 480. So each layer has a potential of being about 400,000 tiles. And remember I said there are 4 vertices per tile. So 1.6 million vertices to render this map per layer, potentially. That's a lot. Unity has a limit of 65,000 vertices. But don't worry, UTiled has got your back. So, let me go ahead and minimize this. We're going to generate collision on the platforming layer only. It's going to take a second to read the map data. This part here, you don't actually, this dialogue has been up every single time, but
you haven't seen it.
No, you haven't seen it. It flies by too fast. So now we're generating prefabs for the layer room guide here. It'll have to go through. Now, room guide is by far going to be the slowest one. In fact, if I come back to tiled here, you don't want to see that. You saw nothing. If I come back to tiled, room guide was this layer that we made that just sort of outlined the colors meant different types of room, different themes, save points, etc. That was what room guide was. So we shouldn't be loading that at all. We should just turn that off and not import that at all. But it has a tile in every single square of this map. So it's really going to give a workout. Even the background is only in the tile layers, or in the actual render map zones. How we doing? Okay, we're on the background now. So, we're moving along.
Should go a little faster.
Yeah. This progress bar at the moment only jumps between layers. So, I may come back later and make it implement more of a scrolling per vertice count or something. But for the moment, it gives you some idea. Things are moving. Things are going. No, just keep calm. Carry on.
There's stuff happening. Don't worry.
Don't worry.
Hasn't locked up.
Everything's fine here. How are things with you?
How are you? Everything's fine.
Platform layer is kind of huge. Merely because I went ahead and outlined our entire map. That made it a quite large thing. And also, I'm generating collision mesh for platforms. So it's going to go and do a vertice reduction, a very basic and crude vertice reduction, but it is going to simplify that mesh for us somewhat. And we're probably just about done. I'm hoping we're just about done.
Eventually.
Like I said, my progress bar does not really indicate true progress. We could be done any moment. We could be right here, right now. And we were.
Again, this is an extreme scenario.
This is an extreme scenario to show you how it's going to be handled.
Like,
now, I'm going to go ahead and let this go to 720, because that's what we sized Captain Dubstep for, was 720p. And I'm going to come grab our moon base prefab and drop that sucker on there. Zoom way out here. Since I went to 720, I now need to set our camera to 360. For it to dial in the pixel perfect stuff that we talked about. I also need to really move our camera. Our camera needs to get up here somewhere, like to the start of the level. I'm going to go ahead and adjust this guy a little bit. And let me make sure I get off the decimal places so that I'm changing whole pixels. If you leave decimal places in, Unity will let you slide by decimal places. If you take decimal places out, Unity will actually do the right thing. And go by integer values. So that's good to know. Okay, so that's kind of how we sized up the intro screen to be of Captain Dubstep. And I'm going to go ahead and let it run here for a second. Oh, wait. Let's let it maximize. I'll turn on the stats here. So, verts that we're dealing with right now, 150,000 vertices. It's a lot. Like I said, don't do what we have done. We're just kind of showing you.
Yeah, in theory, you would be splitting this up, and how you handle that in Unity may differ. You may have a scene that loads and destroys different prefabs. You could have a scene that, one scene per prefab, where you have other Unity objects in there interacting with the tile layer.
Many better ways to do this than what we have done here. So, here, you can still see, though, we're still over 60 frames per second.
Yes.
Now, granted, there's not an actual game running.
I found that stat counter runs higher than I usually expect for things, though.
Yes. Expect a lot less. So let's see what we got in Moonbase. So in Moonbase, there's the background, which is just the bits that we filled in. The invisible blocks, we have some blocks that you can't collide with placed. So there's kind of some background extra decoration blocks. The platforming layer, which has our collision layer, which, if we drill down into here, so you can, every sprite sheet is going to cause another mesh to be generated. So in this map, come back into tiled, you can see we had several tile sheets by the end of it, and we didn't optimize really at all. Okay, our tile sheet, we were just in the get it done stage for during build play. So each one of those, where it used the level tiles in texture, that's going to get a mesh. Where it used rocks is going to get a mesh. Where it used ship is going to get a mesh. And where it used tile set tiles, one we actually call tile set, is going to get a mesh. Level tiles actually got 3 meshes. And I don't know if you could quite make that out. I'll zoom in a little bit here. That's because the level tiles mesh was so big, it hit 65,000 vertices. So it went ahead and started making a new mesh to put the rest on, and then a new mesh to finally finish up the rest. So if you can kind of see that, I'll try to frame back up here. You can kind of see this go down. But because I did the mesh reduction, I was able to put all of those vertices on one collision mesh. So if we were actually, and again, not recommending this is the way to go.
Yeah.
But if we were actually to use our platforming layer like this for our collision mesh, which, let's just see, for fun, our platform's collision mesh has 55,000 vertices. It's a lot of checking to be going on there. If we were actually use that, at least we wouldn't have to check 3 separate meshes. It would be a 1 mesh check. The room guide, as I told you, the room guide goes throughout the entire map. You can actually see it because it had to generate 26 meshes for all that to get on there. So you can actually see it go down each one of those meshes that it generated to pull all those together. If you're doing something this big, this is really where having the slider, like if you wanted to set the opacity on all the background, comes into play. You move my camera over a little bit, and there we go. We can see some of that backgrounding. You can see the opacity change happen all at once, and that's where it gets to that. So that wraps up this quick introduction to Tiled. And just to recap, we support tile layers. We support tile flipping and rotation. We only support orthogonal maps. We do support map properties and layer properties and the layer opacity. So if I wanted to come, remember earlier, I don't think I actually showed this, but I changed the opacity for the level, but I could actually come in here. I can come into our collision layer and change the opacity in Tiled. Save it. That went much quicker than Captain Dubstep. I gotta put our camera back to normal coordinates and set us back to 240. But you can see that the opacity imported about where I had it set in Tiled, so we support that. As you just saw, we don't have any size limits as to what we will import. Use with caution, but there's no arbitrary limits in place for the size of your tile sheets, the size of your maps, or anything like that. In fact, one thing I didn't show here is right now this is a non-power up to 2088 map image. If I was to come here in the compressor context and drop this sucker down to something horrible, let's say 64, okay? Our tiles got really blocky and ugly looking and pixelated, and there's all kinds of artifacting happening there, but it did work. The reason this line popped up is when it compressed it that hard over here. I guess I can't zoom in. When it compressed it that hard, let's set it back to normal. This blue tile is right up against the bottom of that black line.
And they merge. Basically.
Yeah.
But
we do support, if you need to come in here and do texture compression, go ahead and do texture compression, and you don't have to worry about any kind of coordinate mapping or anything between Tiled and Unity. Also, like, you may do texture compression for iPhone or for Android. You know, mobile devices, you may go ahead and override the formats, and don't worry about that. It'll do the right thing. And the last thing is when you create your maps, they do need to be, I'll come back into map properties. They do need to be either XML or CSV based. We don't have any support for any of the compressed or even base64 yet. They need to be either XML or CSV. We will, of course, those will be added. It's just not something baked in Mono like it is in .NET 4. So, I'll just have to find some implementation of that and use it. That sort of wraps up. More's to come.
Yep.
Thanks for watching.